Chakraborty, you can hear me, right? Anyone can confirm if you can hear me? Yeah, okay, okay, great. Okay, so welcome to this lecture where we will continue our discussion on identities. If you see this identity management, which is the current topic that we are discussing. And in our last class, which was last Thursday, since it's been quite a while, I'll quickly recap what we discussed. So we had a working definition of identity, and then we explained that normally digital identity are maintained in the form of some centralized services, and also what are the difficulties with that, the kind of attacks that might take place. Then we talked about single sign-on, where we log in one site, and then that authentication is propagated to other sites also, and you don't need to sign on again and again. We also talked about the need for decentralization, that SSO by itself inherently does not ensure any form of decentralization. Also, we said that other than the digital identity, there is a need to actually verify physical identity through processes like KYC that we have. The mobile companies or the banks or other services might be doing that. Then we said that we'll try to go for decentralization of digital identity, and by usual process, there are difficulties in verifying the identity issuer and also the identity holder, because there could be again certain attacks that could compromise the security. And then we talked about the fundamental principle of digital identity management, which is what is called self-sovereign identity, meaning that as the holder of that identity, I should be in a position to decide which part of that information to be presented to which particular verifier, or for getting a service, I need to share certain things. So I should be in a position to control my privacy. So an analogous situation occurs that you install an app in your smartphone, and then it will ask you for permissions to access certain features like your microphone or the file system and so on. So you are able to decide which ones you want to give. And often what happens is that we get to know that, see, if I want to use this particular app, then I'll let it get access to my file system, or like say my camera or my microphone and so on. So then I might want to decide, no, I don't want to have that app because it's asking for permission to access a lot of such information and services in my phone. And then I might decide that no, it's better that I will not rather use this particular app. Now, similarly, that if you want to get some service, and for that you have to present your identification, and a lot of such data is to be shared. So you may finally decide not to really go for the service, because it might actually asking for a lot of your private information, and you might not really be sure sometimes that why it is asking for so much of information. So that is what is the concept of self-sovereign identity. And from there, we started our discussion on decentralized identifier, or DIDs or DIDs. Now, these decentralized identifiers, the DIDs, they provide a verifiable, decentralized digital identity. So it's important that it is verifiable by a third party, and it is decentralized. And of course, it is a digital identity. And it has been designed so that the identification process that is decoupled from centralized registries that we talked about, the providers of the identity, and there will not be any certificate authorities. This also we discussed in our last class. And the holder of deed can prove its ownership on the deed without the help of any other party, and it's a W3C proposed recommendation. And it's important that I'm showing you this particular link, that you I would encourage you all to take a look at it, because if you go to this site, and I believe this also you can see because I've shared the entire screen, is that It has got a lot of interesting details, and you can start looking through this contents page and go to the required sections, or maybe, yeah, it's sections of this document. And this is written in a very lucid manner, and it's very easy to follow, and they have all these different hyperlinks to take you to appropriate other glossary of item of these terms and so on. So you can actually will find this particular document very helpful, and there are several examples as well. So please feel free to actually visit that w3.org site, and you can take a look at the details. You really do not need to maybe look at all the technical details about all the exact formats and so on, but at least to get an idea about what this deed is all about, why this particular effort is being made by W3C, which is the World Wide Web Consortium, you will be able to appreciate that. So the deed architecture. Now, let us understand what this deed is. Is that this deed has got a URI like this one, and we'll see some details of that. Okay, so we'll see in the very next slide what it is all about. Now, the main components, if you see that there is a verifiable data registry. So there is this data registry where all the different types of data would be stored. That is the first thing. And what is stored there? These deed documents are stored there. And what is a deed document? A deed document refers to some information, and details of which we'll see very soon, about a deed subject. Okay, so a deed document is about a deed subject. So it could be, for example, I as a sub could be a subject, you could be a subject. This could be also some organization, or it did not be a human being. It could be anything else. Okay, about a pet or something. So we could form such types of deed subjects, and there is this important entity called deed controller, and this deed controller is the one which is responsible for actually uh, creating and updating deed documents about a deed subject. Again, let me repeat: the deed controller, this controls the deed documents, meaning that, say, a deed subject wants, say, I would like to get a deed document created for me, and I might not be the person who is entitled to create that. It could be a particular deed controller who would be able to create that document for me, and that deed document will then be kept in the verifiable data registry. Now, each deed document actually has this particular deed URL, which will have all the exact location. And this deed is defined in terms of its URI, and which resolves to this particular document. And this URL actually contains this particular information, and it refers and dereferences to the deed document. So what it means? It means that this deed actually would be uh, referring to the document, and this document is there in the registry, and the document would be kept in the data registry at the time of its creation by the deed controller. And if there is a need to update the information in the deed document, that controller will be able to do it. But this will be referring to a particular deed subject. So this deed subject will be using this for proving its identity, and it can only do if there is indeed a deed document referring to that particular deed subject, possibly created by a deed controller. But also we need to keep in mind that sometimes a deed subject and deed controller could be the same. Means I could create my own particular identity, and also, of course, we'll see that if we create it for me, then I can only claim certain things, and if it is created by the controller, some more types of information could be added, and we'll see some more about that very soon. So if we see the flow of information in the form of the sequential steps. So first of all, this deed, it is a unique URI which identifies a subject. Okay? And just before, yeah, so right, yeah, fine. So identifies a subject which is recorded on this verifiable data registry, and this entity, which is a person, organization, and whatever is being identified, is the DID subject. And I have already mentioned that this is the DID controller, and DID document contains the information which is stored in the verifiable data registry. But now, one point I would like to mention here is that you might wonder that we are talking about decentralized identifier and all, and then we are saying that there is one such box where the data is being maintained, all these DID documents. But although that is being depicted here, actually this data registry is decentralized, and we'll see some ways of implementing such types of decentralized data registry. That is the goal of this part of our discussion here. Now, DID URI. So DID is a unique address URI to the location of that document. So if you see this, you can actually see what is the format of URI by going to this RFC, and where again they have given all the detailed information about the structure of URI and what each of these fields mean. So you can take a look at this particular document as you are going through the slides. So it is a unique address to the location of that document, and it usually would have a scheme. So this scheme is like, say, for URL you have HTTP. So similarly here for DID URIs, the scheme is always DID. So this is to be fixed. Now, this second part of URI, that is the DID method, system which supports DID scheme, for example, DID resolution. So what it means is that this will tell us that what is that method that is going to uh, uh, implement the functionality of this DID. And this implementation, as I said, that it is about decentralized data registry, and this decentralization can be achieved through blockchains. And say if it is done using Ethereum, so then this Ethereum could also be that example of the DID method, which will actually do the resolution. Now, within this particular method, we have a unique identifier which is specific to this method. For another method, there this particular identifier also might repeat, but within this method, this is a unique identifier which identifies a particular DID document within the DID method. So with this whole thing, DID, then example, and this particular DID method specific identifier, they together identify a unique DID document. Okay. Of course, because all of these are DID, so now different such DID methods can possibly repeat the same identifier, but these two together then will become unique, so that only a particular distinct DID document can be actually identified. Now, the point is that we are talking about DID document, but what does it look like? Okay. Now, a DID document, if you once again see this here, that this DID is having this type of URI, and then it resolves to a DID document which is stored in this verifiable data registry. And what is that DID document? That is what we are trying to show here. A DID document is a set of data describing the DID subject. So all of these are actually referring to this same document, that link that we have here. So if you click on, say, the DID subject, it will take you to the DID subject part of this one. So if you just go to DID subject, and you will be able to get this thing here. Okay, and there, if you click on DID subject, you will get to see all the details about DID subject. So who all can be this DID subject. So this also includes mechanisms such as cryptographic public keys that the DID subject or a DID delegate can use to authenticate itself and prove its association with the DID. So it consists of a map of entries, and we are trying to see what this map is, and each entry consists of a key value pair. Because of course you see that this is a very flexible type of map, where we'll see that there are certain properties which are mandatory. There could be some extensions and so on. So we cannot have a very fixed type of schema that normally one would see in relational databases. Rather, it is important that we have the data stored as key value pairs, and we'll quickly see some of the formats. So Now, there are certain properties and there are certain representation specific entries. So these properties, there are a few core properties and there are some extensions which one can add, and there could be some custom defined extensions also. So the core properties typically are the ID. ID basically means what is that identifier, and that would be the part of the identifier as it's mentioned here. Also known as, so if there are aliases for this particular subject, so those can be mentioned. The controller's identifier, so that is important. The authentication that will be used and the way the verification would be done. So for example, we'll see that if it is done using public key, so all these types of information will be mentioned that this is public key. And if it is public key also, then what kind of public key cryptography is being used, it is RSA or something else. So these types of information will be stored in the form of verification method. The service and service endpoint, so these are also important because they denote that what is to be done in order that once that authentication has been done using this identity, then what you can do next. So where do you get information about the next steps of operations using for that particular subject. Some of the extensions, like as I said, that if this is based on Ethereum, so Ethereum address could be there as property extensions, or other types of information could be included in property extensions. And representation specific entries means how this data is being represented. So whether we are using JSON to represent all these, or we are using XML or anything else, so that is what will be written here. So the core representation specific entries would be like, say, if it is JSON or so, and there are other types of extensions if you need to keep for the, like for uh, there could be even some unregistered representation specific, like if there are not the standard ones like JSON or XML, so you could also have those ones added here. And likewise, so there are certain standard types of extensions, and there could be completely different types of extensions in the deed document. Now the question is that what is this service and the service endpoint, what they are doing. So it means that, say, Alice is authenticating itself, and then to some verifier, and then the verifier so will get this URI of Alice, and then using that URI, so as we showed here, that this URI will resolve to a deed document, and it will know where that is kept, in which data verifiable data registry it is kept, and then it will be able to open it and see the content. And based on that content, if everything is matching, then now it will be able to reach Alice. Okay, like it is now Alice's website or phone number or whatever. So that is what will be this service endpoint that will be stored here. So we'll see one example. So if you see here that we have this ID, and which is like we took the instance of deed example, and then this is the method specific identifier. So it is a deed for a particular deed subject. Now, if you see here also, there could be this also known as, and so on. If there is a controller also written here, that would mean that the controller is not the same as the subject. Okay, and if that is not the same as the subject, this controller details will be written here. Now if you look at this example, this ID means ID of the subject for whom this deed document is being kept in the registry, and then the controller also, you will see it is the same ID. That means this is an identifier which is being self-certified by the subject itself. If not, the identifier and the controller, these two would be different. Now, what you might wonder, what does that mean? So this is, if you can think that it is that I say that this is my public key and I want to store it here, and then you can get this information for authenticating myself using this verifiable deed registry, and then the further steps can actually take place. So now, although it is written as public key here, so the public key is a way it will be verified, and this is not RSO, it is ED, then 25519. So this is another approach for this public key cryptography. So it is a verification method how the deed subject can authenticate itself. So this is what we have here as a verification method. So it could have been RSA also if RSA was used. So you have other public key cryptography techniques, and the public key of this particular subject whom this particular deed document refers to. So that particular subject's public key is stored in an encoded form here. Okay, so this public key multibase is a multibase encoding of the public key. So all the details are mentioned. And the service, as we said, that it here we said that service and service endpoint. So it denotes the ways of communicating with the subject. Okay, so it tells how to reach the subject. Otherwise, even after authentication, you do not know what would be the next step. So the service endpoint tells us that you now go and hit this particular URL. So that means that after the authentication, you go to this particular service endpoint to get to the next step of processing what you intend to do after authenticating this particular uh, user or the subject. Also note that there is no sensitive information in this read document. So as such, this is only storing the public key. Now, what is the role of the controller? The controller can actually say that, okay, so for this ID, which is for this particular subject, this is the public key which is stored here, and in order to get for the service from this particular ID, then you have to go to the service endpoint. And what we have not shown here is that these ones, like it is, as you can see that it is example is in JSON. So what we'll have here is that it will mention that it is in JSON and so on. So that is the that is how a did document looks in a did verifiable data registry. And the did controller, if you see the flow of information, did controller actually controls a did document. Okay, and this particular did, this identifies a did subject as we have seen, and this did document describes that subject, and this did resolves to this did document, and the controller actually controls this did. So so as you can see that this is very simple, that what this deed is all about, and where they are stored, and as mentioned, they are stored in a verifiable data registry, which the whole point is that which should be decentralized. Okay? And sometimes, of course, the deed subject itself could be the deed controller. So basically these two are equivalent. It is same as the previous diagram, except that this deed controller and deed subject are the same. That's pretty simple. So if we see the flow of the did flow, the did registration process, and here is an example where Alice is itself registering its public key in the did, this verifiable data registry in the form of a did. So if you look at this, so Alice is generating keys, the public key and the secret key, creates the did document as was shown here, like this kind of a document where these pieces of information are kept as part of the core properties, and the service endpoints are mentioned like this. Now, then this create document, now it will be there. This is the did document. Okay, and say the authentication method is using public key, and if you look at this controller is also same as the ID. That means it is a self certification by Alice, and then this did document, which is signed, this is important, signed by the secret key of Alice, and that gets stored in the verifiable data registry, and this will be updated in the deed document. And then what this once it is there, now Bob, suppose Bob wants to authenticate Alice. So what Bob will do is that Bob will get the URI of Alice, and it will fetch the deed document, and then what it will find, it will find that it will find the public key of Alice in that deed document. Now, how does it know that it is indeed Alice? So Alice will have to prove to Bob by signing any document which is by the secret key that only she knows, and then this document can be decrypted by the public key that Bob has got from the deed document. So that is how this authentication will be done. And once this is authenticated, then Bob will be able to get the service endpoint as was mentioned here, like this. to get to now communicate with Alice for the next steps. So that is basically the overview of how this deed flow is established and how one can prove control over a deed. And of course, if indeed the controller was different, then the first step would not be by Alice, but it would be by the controller, and then it will be added to this verifiable data registry by the controller. And if required, say for example, somehow the secret key is compromised, then you have to also update the new this public key, and that will also be done by the controller. And in case of self certification, then the subject itself can also do the same. Now, what so far it looks good, but still it is all that we are talking about, some overview and how exactly do we implement and how does it come into picture in the context of blockchains. These are all something like good efforts by W3C to have decentralized identifiers and so on. So, uh, so deed registry ideally enforces deed method protocol. So it will ensure that the deed method. So again, just for your recap, so deed method was this one. Okay, so this registry will be actually enforcing these deed method related protocols, and centralized, of course, deed registry would bring in risks. Okay, and one can manipulate the deed documents. The verifiable data registry, that service itself might do make certain changes. Okay, and also it might censor some DID documents that, oh, if you ask for this, then I will say no, it is not available, and so on. So I could, I meaning the centralized verifiable data registry, which might then cause certain types of such denial of service and so on. And lack of transparency, meaning that the subject really does not know what exactly is kept on that verifiable data registry, because the verifiable data registry is not accessible to the subject otherwise. Okay, so uh, the the reason why we are talking about all these things here, this identity management and then uh, decentralized identifiers and so on, because now that we see that we would like to have this uh, not centralized deed registry, so it should be distributed. And of course, the one of the ways of doing that, the technology that we can use is of course blockchain. So uh, this blockchain based implementation of verifiable data registry, that indeed would be a good solution. Then you see that some of these problems will be handled. Okay, that this centralized data registry, so it cannot manipulate the documents, because if any manipulation now is done, of course, as we know that it is difficult to manipulate something. And also if it is available and then the centralized registry says that no, this particular deed is not available or something, then also it can be always verified that whether indeed that is true or there is some kind of unusual processing that is being done by the data registry. So this lack of transparency, that also will be gone. So the goal is to have this verifiable data registry actually implemented using blockchain. And remember that also we said here that this deed registry ideally enforces deed method protocols. So that means that these methods will be implemented by this now uh, data registry, which is implemented using blockchain. And the way to do that is by using smart contracts. And smart contracts would enforce how authorization is performed to execute all operations, including all necessary cryptographic processes. So all these steps, the methods that we talked about, these will actually be handled by the smart contracts supported by the blockchain. And now that we have a transparent immutable ledger, it will allow verifiability of deed documents. Any party can always validate if a deed documents creation updation transactions were authenticated or not. For example, say a controller C creates a document for Alice A and then claims that, oh, this is my public key. And I have actually uh, signed this, or I have actually created this particular deed, then of course, based on the public key of that particular controller, one can easily verify indeed whether it was created by him. Also, that information is being stored in the ledger, so that later on the controller cannot also go for repudiation that no, I did not create it and it was done by somebody else in my name. So those non-repudiation, etc., can be enforced if we have this all the data registry maintained on the blockchain. And of course, as you understand, that it would also be decentralized, and as a result, if there is one node fails, the data also will be available in the other node. So there is no one point failure of this centralized data registry. So that is the goal. And indeed, there are these two options. One is that the side tree. Okay, so interestingly, what they do is that it's a protocol for creating scalable deed networks, and that can run on top of any existing permissionless blockchain. So they have implementations on like Bitcoin. So one can do this, that the underlying blockchain could be anything, and on top of it we build a layer of this decentralized data registry, and side tree is one option. The other one, which is of more importance to us at this point, is that this Hyperledger Indy. If you see the different projects under Hyperledger, including we have seen Fabric, so they have this Indy project. Now, this Indy project is important in the sense that it is actually a public permission ledger based registry. Okay, so if we take a quick look at Hyperledger Indy project, we'll not go into its details. So if you see it here, that it provides all these uh, tools, libraries, etc., for providing digital identities rooted on blockchains. Okay, so that is the purpose of Hyperledger Indy, and that indeed is going to solve this problem of the centralized data registry and the requirements of a decentralized deed registry that can actually be handled by Hyperledger Indy. Now, it is a public permissioned ledger-based registry, meaning that, so this part you can see that there is this notion of public but permission. So if you remember that permissionless means anybody can change the data in the blockchain, and and public means that anybody can read. So, and permission would mean that not everybody can change it. So if it is public permission, means that anybody can read the ledger. So anyone in the world can read the content and verify it, but only selected parties are allowed to write to the ledger. So we can make some of the parties like as controllers, and who are the ones who will be able to change these entries in the Hyperledger Indy. So this notion of controller, if they are different from the subjects, then the controllers would be only given access to write to Hyperledger Indy, and then they can create the deed documents. But these deed documents now would refer to different subjects, and once it is say Bob is a controller who inserts the deed document for Alice, and because Bob has that permission, but Alice might not be able to do it for anybody else, but Alice will be able to read it, and for that matter, anybody other than Alice or Bob also would be able to read it and verify it whether everything is in order, because it is a public permission ledger. So what we'll do is that in our one of our tutorials and an assignment, we'll actually look at this Hyperledger Indy. So that is the goal, and when we do that tutorial and the associated assignment, you will also be able to now understand what this Indy is doing, because now you have a better understanding of what is this deed and the verifiable data registry and so on, and what are the requirements of a verifiable data registry. So that is the first part about uh, uh, this notion of deed and how it can be implemented using Indy. So we'll see, of course, the details of how it can be implemented using Indy. So that is the first step of having a decentralization of these identifiers, the digital identifiers. So far it is good, but there is still something which is lacking in the discussions that we so far had. So if you look back a little bit, we are going back to these ones that when we talked about this part. So if you look here, so the identity database, the identity provider and all, so they are maintaining the digital identity. And then on the other hand, we have the other loop, as you can see, the mobile companies for user identity verification and the user. So this actually provides the physical identity like KYC and all. Now, so far what we talked about here indeed, these are again all digital identities. They have nothing to do with physical identity. It is all about a public key and so on and other details, but these are all in the digital space. It does not bind this particular user to any specific physical identity. So I could just say that I am Shamik, and then everything is there in terms of Shamik, but who that Shamik is and all, that is not there anywhere in this whole picture so far. So the next step, of course, is to bind the digital identifier, the decentralized identifier, to physical identity. Okay. So if you see that the deeds, they only allow a deed controller to prove its control over its deed documents. Okay. And this is useful to authenticate an entity with respect to its deed, and it is nothing more, nothing less than that. Okay. So if you see that, say, Alice has this public key secret key pair, and authentication is based on public key, but it does not reveal any physical detail, right? What is like, say, Alice's date of birth and any other things, okay, or address or citizenship and so on. So what it simply does is that this authentication will fetch the deed document and where the primary key is stored, and based on that, this will be done. So if there is any physical detail, like if Alice mentioned that, oh, this is my date of birth, this is my citizenship, so these are some self-attested by the deed controller and not any verified information. Okay? So if you remember that we had a lot of other details which could possibly be kept here in this example, okay, that we can have several like also known as and so on. So there we can have many such entries made, but still it's not actually mapping that with any form of real physical identity. The deeds are not inherently tied to any physical identity. There is a real world identity. Okay. Now, there comes this concept of what are called verifiable credentials. Okay. Now, here we need to uh, first understand what is that we are talking about in terms of verifiable credentials and what is the important part of it. So, if you look at the physical world, and we can have different such physical world credentials where say I could have a driver's license, I could have a passport, I could have maybe my birth certificate, I could have certificates from my university saying my showing my degrees, and then maybe another certificate also from the university which shows my grades, that is a transcript. Or I could have a single document which have all these uh, the both the degree certificate as well as the transcript together in a single document, and there could be so many things. And we carry all these physical credentials which we can also present to some verifier. So if there is a need to show my identity while checking in at a hotel, I could show my say driver's license. Okay, it does not make sense to show my birth certificate. Okay, now for applying for a job, I need to show my maybe the degree certificates. There also they might be interested only in knowing whether I completed my masters. They might not really be interested in checking my grades. Okay, like for example, for say applying for passport, for getting certain things like ECNR, etc., stamped appropriately by the passport issuing authority, you have to show that you have completed, say, an undergraduate degree or whatever. Now, for that, you don't need to show your transcripts. But for applying for maybe some other university, you might be required to show your transcript and so on. So what we are saying is that here this notion of self-sovereignty is there, that I can decide based on the requirement which part of the credentials to present. Also, it is very, very convenient in the physical world to present these to different such verifiers and then get appropriate services from them. Now, this whole movement of verifiable credentials, this was made with the goal that whatever we can do in the physical world, something similar we can do in the digital world. And if we can do it in the digital world, actually things will become more efficient. Say I want to apply for, say, a project position at IIT Kharagpur. As long as everything can be presented online, then things are good. If every applicant has to send hard copies, first getting it attested or self-attested, and then post it and then send it to Kharagpur, then somebody will collect, and at the time of selection, all those will have to be compiled and put together and verified. So those become very, very difficult, and this becomes really inefficient also. So it is important that these credentials should be digitally verifiable. So the goals are to decouple issuer, holder, and verifier. The issuer is the one who issues the credential. Holder is the one who is currently holding the credentials. That means this has been issued by the issuer to the holder of the credential. And then a verifier, which is going to verify the credentials once it is required for some getting some service. So, for example, if we have the university issuing a certificate to me, then university is the issuer, and I am now holding that credential. And then the verifier is, if I present it for a job application, then the industry is now going to verify that. So these are the three different entities, and they are decoupled. Okay? So there are the issuer is not tied up with the holder, or holder is not tied up with the verifier, or the verifier is not tied up with the issuer. Now the problem is that if we want to do it everything in the digital world, then we have to ensure that there is some inherent security in the whole thing. That means the first of all, holder cannot present a credential which is fake or something and say claims that it is from the issuer. As we have seen in the physical world, we say that, oh, if it is with the signature of the dean, then it is considered to be authentic in the physical world. But also remember that in the physical world, the chance of doing counterfeit, generating counterfeit certificates is much higher, and it is much easier to do, because if somebody presents a certificate with a forged signature, or even signature, or just some signature is put, see, the when you are presenting it to, say, a company for a job, they are not going to even know how the signature of the dean looks like. They will see that, oh, it has been presented, and it looks like it has got IIT Kharagpur and so on written, and then there is a signature, and then they might trust it. But it is not always easy to even verify. So we will see that it is much, of course, easier to verify these things in the digital world, because we can make use of these digital signatures, and they are, of course, you cannot tamper it. So this whole process of these verifiable credentials, this should be secured using cryptographic means, and not only the issuer to verify, like the verifier should know that this is an authentic certificate which is indeed issued by the issuer. Also, it should be the case that one holder, say one student, cannot present some other student's credentials, because again, that will be done through the public key, private key pair um, of the student. So that is about making use of the digital signatures once again. So whether it is students or anybody else, it would be handled by these cryptographic techniques, typically digital signatures. And privacy respecting, in the sense that, as we said, like the self-sovereign identity concept, that not everything would be presented to everybody. So that is one aspect. The other, of course, is that one should not be able to present it on behalf of another. So Alice should not be able to present Bob's details, so that Bob's privacy will be violated. And machine verifiable, this is very important. All the concepts that we are talking about, it will make sense only if the verifier can verify it without having any human intervention or manual intervention, and then uh, it is whatever is there in the credentials, there should be some way of knowing its schema so that the machine can verify it, because only when the machine can verify it, then the things will be much more efficient. As I said, that if you try to present your physical license, okay, then it will not be machine verifiable. Also, I'll give you one more example. You might have heard of this notion of digital locker these days, that you have your several types of information which can be kept in the digital locker by the issuer. For example, for your uh, say certificates and mark sheets of your board exams. So these can be put in the digital locker, like licenses can be put in the digital locker. But mind it that it should be put there by the issuer. So I cannot put my own certificate there, because then I could just put whatever I want. So these are like the verifiable credentials which will be put in some digital vault like the DigiLocker and so on. Now, one point to note here is that, say today people talk about that you don't have to carry your physical license if it is there while driving a car, if it is there in your digital locker. So if a cop stops it, you can claim that, see, this is the location and here you see my license is kept, I don't need to carry it physically. Now, this is one step where this issuer has actually kept your credential in the in that repository, which of course is one step forward. But remember that still it is not machine verifiable. Okay, that means that now the cop can actually visit that and see physically that indeed there is this particular license issued in name of this particular person. Okay, now uh, if we talk about machine verifiable, so that would mean that one can actually read the various fields of that particular license, including the license number, state in which it was issued, and whether can drive light vehicle or a heavy vehicle, and so on. So some of these may or may not be machine verifiable all the time. But again, in other cases, like where you are presenting, say, your Aadhaar card for getting a new SIM card, okay, and you are presenting your fingerprint in their small device. So there, it can actually you see that it is machine verified. So you don't have to give these physical hard copies of your self-attested Aadhaar cards and so on. So you can verify everything online, and as the SIM gets issued, you get that as verified information. So these are some examples where actually you have these physical credentials stored in such a way that they become verifiable digital credentials. So that is the concept that is important, and that is something we are seeing how to actually implement. Okay, so if we consider these verifiable credentials, or VCs in short, okay, so they have these different components. Okay, one is the issuer, there is a holder, and then there is a verifier. Okay? And then there is a verifiable data registry where certain things are kept. So let us understand that which component is what. So issuer is like, say, the university, or say the UIDAI who are issuing our Aadhaar cards. So they are the issuers. Okay, and then they will be issuing these to holders. So say us, or the university can give it to students. So the holder acquires the credential, it stores it, and then when there is a need to get it verified by a verifier, we'll be presenting it. So we have this acquiring, storing, and presenting it. So when the verifier demands for the credential, the holder will be sending to the verifier a presentation. The presentation means that it is a part of the information that is there in the VC that the holder is willing to present to a verifier. So like this case of our both mark sheet as a certificate, if that is the credential that has been issued by the board, okay, now if I want to simply present to a verifier that I completed this particular say exam, like your +2 exam in this particular year, say 2017 or 2018 or whatever, okay, I would like to present only that part. Okay? But if it is about job, then I might have to present my, or a university for another admission, then I have to present more details. So I can create a presentation out of the credential and then send it to the verifier, and that would also be honoring the notion of self-sovereign identity and privacy and so on. Now, what is the verifiable data registry? So you see that the issuer, how do you know that it is indeed the correct issuer which is issuing the credential to the holder, and then the verifier, how would it know that this is indeed an authentic credential? So the issuer's did will be entered in a verifiable data registry, meaning that its identifiers, the decentralized identifiers that we talked about, those will be kept in this verifiable data registry. And again, if we remember what is there in the deed document, so it is going to store the deed document corresponding to the issuer. So it will have the public key of the issuer and which encryption technique is used and so on, and also the schemas. So if this IIT, say IIT Kharagpur stores your credentials, the VCs, verifiable credentials, in this is going to issue to you the credential, then it also has to somehow store in that data registry what is the schema, like what are the different fields of it. Because if it is to be machine verifiable, then the verifier, which if it's a machine that is doing it, it should be able to not only verify that this is an authentic piece of credential, but also it should be able to read the individual fields from there. So for that, it has to know what is the schema. And that is what this issuer will be actually keeping in its date document in the verifiable data registry, and then issue the VC to the holder. So holder acquires that, and this VC, which is like a digital certificate, which the holder will store. Okay? And then also what it has to do is that it has to use the schema. Like, so if it wants to present only say part of it, then to a verifier like only the pass information, then of course it has to use the schema to determine which are the fields that are pertinent for only the pass information. Okay, and then if it is about the entire transcript, then what are the fields which are important for these marks and so on. So it has to use the schemas when required, and also it has to register its own identifier. So its own did also will be stored in the verifiable data registry. We'll see why that is important. So that is the first part, that is the issuer issuing a credential or multiple credentials to a holder who acquires it, stores it, and if required will be able to present it. And the issuer actually will put its identifier, the did having the public key and also the schema for this particular credential in the verifiable data registry. Okay, and the holder also insert its did in the verifiable data registry, and of course will use the appropriate schema for creating the presentations. And when the verifier is asking for the credentials, the holder will prepare a presentation and send it to the verifier. And the verifier now has to identify two things: that first of all, that it has to check indeed this was a credential that was issued by the issuer. So the verifier will check against the public key of this issuer, which is there in his did in the verifiable data registry, and using that it should be able to check that the digital signature that is there is indeed valid. And also what it can check is that if, for example, it is Alice who was holding the credential and now Bob is presenting it to the verifier as if Bob is Alice. So then how does the verifier know that indeed that credential was issued to Alice, or it was issued to Bob? Okay? So whether it was indeed issued to Bob or it was issued to somebody else. So then if Bob's identifiers are there in the verifiable data registry, then this verifier will be able to check whether indeed this was issued to Bob or it was issued to somebody else. Because then if it is signed, when the holder is presenting it to the verifier, holder will sign it with the secret key that is known to the holder. Okay, and unless it matches with the corresponding public key of Alice, then if Bob presents it by signing it with Bob's private key, then it will not be decryptable by the public key of Alice, which is stored as a did document in the verifiable data registry. Okay, so it has to be indeed Alice who has to sign that presentation and send it to the verifier, so that verifier once the verifier gets this particular public key from the data registry, it will be able to check that it was really Alice who is supposed to present it, and of course also can check that it was indeed issued by the issuer. Say IIT Kharagpur issued it to Alice, and then the verifier can check both. So both the issuer and the holders deed entries are there in the verifiable data registry. So I will stop here. Just make sure that I am showing you this other W3C, this link, where again it is very nicely written what is the purpose of these verifiable credentials and how this can be issued. So as I said, that what happens in the physical world, what happens in the digital world. So all these details are given here, so you can take a look, and these figures are also indeed taken from this document. And so I'll stop here. So we'll go to a bit of more details about how this kind of actual verification is done in by the form of digital signatures in the next few slides. So we have about 5 or 6 slides left. So that will take up after the DP holidays. And with that, I will stop here. If there is any question, you may please ask. And also just wanted to mention that even if now you are still wondering that why we are studying all these things, like that did why we are studying, so that was in the context of Hyperledger Indy, and we'll see that. And likewise, after we covered the few slides that are left, actually we will also talk about this, that this Hyperledger Aries is for creating, transmitting, and storing verifiable digital credentials. So whatever we are talking about these VCs, so we'll use this Hyperledger Aries, the other project of Hyperledger, for seeing how these can be actually implemented in practice on blockchains. Okay? So that is the reason why we are talking about VCs in detail here. So with that, I'll stop here. If there is any question, I can answer. Otherwise, we are going to meet tomorrow. I'm stopping the recording now. So we'll meet tomorrow for the test